Exponential equations. So we saw previously that if you have some base b raised to the x power and some base b raised to the y power, and if those two quantities are equal, then we could say x equals y. You don't cancel the b's. You do not cancel the b's. There's a property that says if the bases are the same, then the exponents must be the same. Great. What happens when you can't get the bases to be equal? So for example, you have something like 2 to the x plus 1 equals 5. I want to solve for x. Okay, well, I can't make 5 have a base of 2, so I would change this to log form. So in log form, this is the log base 2 of 5 equals x plus 1. And so this is -1 plus the log base 2 of 5 equals x. Notice I put the -1 in front. If you write this as the log base 2 of 5 minus 1, it could very easily be misconstrued as the log base 2 of 4, which of course is voodoo, but it's a much safer bet to put the constant in the front. All right, what happens when it's something like 2 to the x plus 1 equals 5 to the 1 minus 2x? Well, what's the base? Is the base 2? Is the base 5? Yes. So it's not as obvious, I should say, as it is in the previous example. But what I'm going to do is I'm going to take the log of both sides. That's going to give me the log of 2 to the x plus 1 is equal to log of 5 to the 1 minus 2x. You can square both sides. You can square root both sides. You can add 1 to both sides. Well, you can indeed take the log of both sides. Properties, make sure you're using parentheses. Quantity x plus 1 times the log of 2 is equal to the quantity of 1 minus 2x times the log of 5. The log of 2 is just a number. It's a fancy number. The log of 5 is just a number, so I'm going to distribute the log of 2. So this is x times the log of 2 plus the log of 2 is equal to distribute the log of 5, and you get the log of 5 minus 2x times the log of 5. All right, we're solving for x, so you want everything with an x on one side, all the constants on the other. The log of 2 is a constant. The log of 5 is a constant. So this is going to become x times the log of 2 plus 2x times the log of 5 is equal to the log of 5 minus the log of 2. The log of 5 minus the log of 2 is the log of 5 halves. Subtract logs, divide arguments. I'm going to factor out an x. This problem is going to take a whole sheet of paper. I'll rewrite that as the log of 5 halves in just a minute. Okay. The log of 5, 2 times the log of 5. That is the log of 5 squared, which is 25, times 2, which is 50. I brought the 2 up and I made it an exponent. 5 squared is 25. Add logs, multiply arguments. 2 times 25 is 50. So x is the log of 5 halves over the log of 50, which reverse change of base is the log base 50 of 5/2. Highly recommend that you watch the video again and go through that step by step. If you're confused about how I just did this last step, the log base b of a, the log with some base of an argument is equal to the log base 10 of a over the log base 10 of b. Or it could be base 6 of a, base 6 of b, doesn't matter as long as the bases are the same. So I did reverse. The denominator is the base 50, the numerator is the argument 5/2. That's how you do a problem with different bases, both raised to an exponent power. Now we're going to look at a quadratic. So what happens when you have 2 times 7 to the 2x plus 11 times 7 to the x plus 5 equals 0. Change that color for you. 2 times 7 to the 2x. That's not 14 to the 2x. That is not 14 to the 2x. This is not 77 to the x. Okay, so I rewrote that. Okay, so we're going to do a substitution. Whenever you see a problem like this, a 2x power, an x power, and coefficients that can't be multiplied, I highly, highly recommend that you do a substitution. So I'm going to say, let y equal 7 to the x. Well, if y is 7 to the x, then isn't y squared 7 to the 2x? Square both sides, but when you square 7 to the x, multiply exponents, you get 2x. That's not 49. So essentially, this is just a quadratic. This is 2y squared plus 11y plus 5 equals 0. This is just a quadratic. So again, how did I get that y equals 7? I just chose y equals 7 to the x. And how is it that y squared is 7 to the 2x? If you square both sides, y squared, and then 7 to the x squared is 7 to the 2x. Multiply exponents. You do not square the base. Okay, well, this is a quadratic. Factor. Factoring life never goes away. Zero product property, you end up with y equals -1/2 and y equals -5. That's not your answer though. This is what y equals. I didn't start with y, I did a substitution and I said, okay, y is 7 to the x. So this should really say y, which is -1/2 equals 7 to the x. Y is -5, -5 equals 7 to the x. It's impossible. This is impossible. It's impossible to raise 7 to a number and get -1/2. It's impossible to raise 7 to a number and get -5. Okay, let's say you don't like that. Let's do rewrite it in log form. This is the same thing as the log base 7 of -1/2 equals x. No, it's outside the domain. So if you can't tell by looking at it, rewrite it in log form. The log base 7 of -5. Nope. It's outside of the domain. Domain for a log is that it has to be greater than 0. So this is no solution. Not 0 with the line through it. 0 with the line through it represents empty set, and we are not talking about sets. So of course we're going to do one where there is a solution. do 3 to the x minus 14 times 3 to the negative x equals 5. Whenever you see problems like this, you should think about using a substitution, which is exactly what we're going to do. Let y, use whatever letter you want. Use A, use B, don't use x. So this now becomes 3 to the x is y minus 14. This should be y to the negative 1. Raise both sides to the negative 1 power. That's going to give you 3 to the negative x. Raise both sides to the negative 1 power. That's going to be 3 to the negative x. So y to the negative 1. Well, this is kind of messed up. How am I going to get rid of this y to the negative 1? Well, this is the same thing as y minus 14 over y equals 5. Let's multiply both sides by y. Multiply through by the common denominator so that you can get rid of the fraction. Let's multiply both sides by y. Okay. Y squared minus 14 equals 5y. Lo and behold, it's another quadratic that will need factoring. I'm going to this way so I can just save myself some room. Y squared minus 5y minus 14 equals 0. Factor it. Y minus 7, y plus 2. So y is 7 and negative 2. That's not your answer. That's what y is. But we started off by saying y is 3 to the x. So 3 to the x equals 7. 3 to the x equals negative 2. Stop right there. No can do. It's impossible to raise a number to a power and get negative 2. Negative 2 is outside of the range. Is it always going to be an answer doesn't work? No. I wish I could tell you that there was some set pattern of here's when you're going to get 2 answers. Here's when you're going to get no answer. No solution, I should say. There's really no set pattern. 3 to the x equals 7. This is a solution. X should be between 1 and 2. The proper answer is x equals the log base 3 of 7. All right, one more. It's a big one. One more, it's a big one. And again, you are more than likely going to want to watch the video again on your own time. Okay. E to the x minus e to the negative x over 2 equals negative 2. Okay, multiply both sides by 2. That's the easiest part of this problem. E to the x minus e to the negative x equals negative 4. Okay, so by now, hopefully you're thinking I'm going to do a substitution. So I'm going to say y equals e to the x. So this is going to be y minus y to the negative 1 equals negative 4. E to the negative x is the same thing as y to the negative 1. Okay. So this is going to become y squared minus 1 equals negative 4y. Okay, how did I get minus 1? Multiply y times y, you get y squared, minus y to the negative 1 times y to the first. Add exponents, you get 0, and anything to the 0 power is 1. Let's set it equal to 0. Not factorable. Yep, gonna have to use the quadratic formula. So that's going to be negative 4 plus or minus the square root of 16 plus 4 over 2. So this is negative 4 plus or minus 2 root 5 over 2, which is negative 2 plus or minus root 5. Let's hope I didn't make a mistake on that. No one's here to correct me if I make a mistake. Ugh, I hope I didn't mess it up. Okay, so that's what y equals. You know, we don't normally write, oh, x equals, y equals, but that is what y equals. And y is e to the x. So negative 2 plus root 5 equals e to the x. Negative 2 minus root 5 equals e to the x. Okay, almost done. So I already know this can't work. I don't know what root 5 is off the top of my head, but I know that negative 2 minus root 5, this doesn't work. Negative 2 plus root 5, I know that does work. So my answer is going to be the natural log. I'm using natural logs because it's base e. This is going to be the natural log of negative 2 plus root 5 equals x. That is indeed the right answer. I cheated and looked it up. Those are some real, what I call big kid problems. Make sure you're working on the homework and coming to class with questions if you have them.